Today I want to show you the Kafka Connect REST API and all the different things that you can do with it. So we're going to start off over here on the actual reference page for the API itself, and you can scroll through this and see the different ways of making requests and the different things you can do. I'm going to work through using a Docker Compose environment, so you can go and clone this repository yourself. It's the Confluent Inc. demo scene repository. There's a demo that I've got called Kafka Connect 0 to Hero, and I'm going to use that as the basis for what I'm running here. But you can run it against any Kafka Connect instance. I'm using Confluent Platform 6, which is Apache Kafka 2.6. If you're using earlier versions, then you might find some of the API differs a little bit. The other thing to bear in mind is if you're using multiple distributed Kafka Connect workers in the same cluster, you need to make sure you've set it up correctly, because sometimes people don't, and there's different ways that you can make mistakes with that. And often when you're using the API itself, you'll notice those kind of mistakes. You'll get errors like this one here, like an error HTTP 409 can't complete a request, or you just find like it starts behaving a bit funny. So there's a good reference here to go and check for that. So let's have a look at this API. To start off with, we're just going to have a look at the Kafka Connect cluster itself. So here's my terminal, and we're going to say, let's do a curl against HTTP localhost 8083, and it comes back with this. So throughout all of this, I'm going to use JQ just as a way of pretty printing the output. You can see it comes back in JSON. So you can see here, we've got its version Confluent Platform 6 and a different commit and the Kafka cluster ID. So that's the first thing that we can do. So I guess we can use that to actually understand information about the cluster that we're connecting to and the version of the software that's installed. What else can we do? We can have a look at the different connectors that are available. We can go and create connectors. Oftentimes, you want to go on and check before you go and create a connector which plugins are available for you actually to create those connectors against. So the connector plugins API lists out the different plugins that are installed. So I've got one on my bash history here because this is one that I use quite a lot. So if we take a look at what we've got here, we're doing a curl against our Kafka Connect worker, and we're using the connector plugins REST call. Then I'm piping it through JQ. Let's break this down bit by bit and see what's going on here. So if we could take the output and pipe through JQ, you can see you get all of the different plugins that you've got installed on that cluster. So we've got Elasticsearch, and we've got the Debezium MySQL and versions. If I cancel that and get this from my bash history, and this time we're going to use JQ just to say, well, for every single instance within the array of objects that comes back, just show the class. We now get this output. So which connector plugins are available on the cluster? These are the connector plugins on the cluster. And the last bit to show you is if we do this, and we take that and we pipe it through grep, and say I've got a particular set of plugins that I'm expecting on my cluster. So these are the names of them, the Neo4j, the MySQL connector, and Elasticsearch Sync. Let's check that all those three are there, and it says, well, here are those particular three. So that can be useful for, like in this case, a demo environment. You need to make sure that before you go and install anything or create any connectors, you've actually got those plugins available. Right, so we've seen here's the Connect cluster and the version of it. Here are the plugins available to us. Now we can actually go and create a connector. So to create a connector, you've got two different options. You can use the post API, or you can use the put. If we post, then we post the information about the connector and that creates it. If we want to change it, we then need to delete it and post it again, which is why I tend to use put, because put creates it if it doesn't exist, and then it updates it if it does. So let's have a look at that. I'm going to use the demo script here for the 0 to Hero talk that I give, but we can see the same thing. So we're in a curl using the put API against, well, let's copy this in and actually walk through it. So we're going to use the put API here against our worker, which is at localhost 8083, and then it's the connector's endpoint, and then we say put, here's the name of my connector, and then here's the config, and then we give it the config itself. So we do that, and we should get a HTTP 201 back. We've created it. The other option, if we have a look at the reference, we can see what this looks like. We can go and create connectors, and we can do a post. Now, if you do a post, you can see here you need to send it the name of the connector, and then config is a separate object within that JSON that you're posting over. Whereas I used the put message, and that was here. So if you use put, you say put connectors and then the name of it and then config. So the actual config is the same, but the payload that you're sending it is slightly different. But put is easier, particularly when you're prototyping and sandboxing and just like iterating on stuff, because put lets you create it if it doesn't exist and update it if it does exist. What we can also do, instead of just using the connectors endpoint, this was added in a fairly recent version of Apache Kafka. You can say expand out the information, and now we're going to get a bunch more details. So let's just run that one, and we can see you get a bunch more details, which is what we asked for. And if we do it like this, and we can pipe it through JQ, and a bit more fancy JQ this time, we pipe it through column, and we can reformat it all, and you end up with this. So instead of simply saying which connectors are running, it says, well, this connector's running. Now, in old versions of Kafka, you had to take every response from that and then iterate through them to get the status. But this call, this API was added in a more recent version, and it lets you say, for all of my connectors, give me all of the information you've got about them. And then this is a bit of bash magic, different commands we can pipe it through to reformat it to give us this. So it tells us we've got a source connector, and this is its name, the status of the connector, the status of the tasks, and then the class of the connector itself that's running. We can also go and delete connectors. So here's my syntax for doing a delete. We've got the name of the connector here, and we're going to say do a delete of that connector, and it's to say I've deleted it, and we're hopefully going to see if we do a list of them, we can see we've not got any more connectors because we've deleted it. And let me show you a good trick here. So this is the delete API, so you just do a delete against the name of the connector, so connector name there. But here, this is a really useful bit of bash magic that someone on Twitter taught me. You can take the connector's output, you pipe it through JQ to expand out the list, and then there's this tool called Pico. Now Pico takes standard in, dumps it on the screen, as we'll see in a moment, and then you can select an option which will then return to standard out. So you can take a list of connectors, show that list of connectors, the user can choose one, and that will get passed into the delete that we want to do. Okay, so we've created ourselves 3 connectors, and we can check that. So what I'm doing here is I'm doing Control R to get bash history search, and because I know that the thing to show the list of connectors has got a sort in it somewhere, I'll just type sort, and you can see it's matching here on the different things. So it's matched the sort there, which brings back the command that I wanted. I can do Control R again, and that'll go back through my history. So we're going to search for sort and go back through R. So now everything on my clipboard history with sort in it then comes up on the screen here. So you can iterate back through those. So let's run sort again and list our connectors. We've got 3 different connectors and we can see they're all running. So now if I do that delete, again I use that clipboard history there to say just go through my clipboard history because I know it says delete somewhere. So it's saying bring me back my list of connectors. Explode it out, pipe it into Pico, which we're about to see, and then the output from Pico, which we'll select, pipe that into this delete call. So we run that, it says this is Pico, this is taking the standard in, displaying it on screen, and we can select through those. We can filter it, we could type in sync, and it matches just on those. We can say, okay, this is the one we want to delete, so we select that, and that gets passed into this call here, this curl call here, the delete against it, where it fills in that connector name. And if we do source and look, do a call against the connectors API again, we can see we've just got those 2 connectors remaining. So creating connectors, put, updating connectors, put also. So if I go and find a put command on my clipboard history, so the connectors we've got running at the moment are Elasticsearch and Debezium. So here's our configuration for Elasticsearch. And I can say, actually, I don't want to ignore the key. I want to use the key of the message when we send it to Elasticsearch. So we say false. So this is going to go and update that existing connector. So we've got a HTTP 200 OK, because it's not create, it's a OK this time. If we do a sort, again, we can see we've still got those 2 connectors, but this Elasticsearch sync one will now actually be running. This brings us on to a next useful API, which is looking at the status, the configuration of the connectors. So we can see here, if we go to connectors, and we're going to go through, and we've got one somewhere which says give us the configuration. And we can say put, and we can do get against the config. So let's do this. We've got this output here, and we want to take that, and this is the name of my connector, and we want the config. And we're going to do a get, which I think is default, but let's put it in specifically. Okay, so now we've got our configuration, and let's pipe it through JQ. So there's the configuration for my connector. There's the name of the connector, and then here, down here, there's the value that we actually changed. So we can see there's the configuration, and it's reflecting exactly what we told it to do, which is what you'd hope it would do. So we can get the list of connectors, we can create connectors. We can also find out the status of connectors, which we actually get using this API here. So the connectors with the expand and expand status argument, that actually pulls back the status of them. But let's say we just want to know the status of this particular one here. So here's, get rid of the config endpoint and say status. And it will say, let's pipe it through JQ. That's status there. Here's our connector, and it says it's running. The connector itself is running on this particular worker ID, and we've only got a single worker in the cluster, so it's all going to be on the same one. But if you've got multiple workers, then that's useful to see where it's actually running. And then we've got our task here, and on which worker is that one running, and what's the state of that task, and what's the type of it. We can also restart our connectors. So here's an important point down here that's called out in the documentation. No tasks are restarted as a result of call to this endpoint. So when we restart the connector, it's going to do some stuff, like the connectors, like the owning controller of the tasks that go on, but the tasks themselves that are connected to the source or target technology with which we're integrating, they're not going to get restarted. So we could do a restart against our connector. So we're going to do a post against this one here and say restart. Oops. This is okay, I've done that. And if we go and have a look at the log file, we'll probably see that it was doing that. So let's do a docker logs f Kafka, oops, Kafka Connect. Okay, so there's our log file. You'll see at the top there it says, okay, I've just restarted that connector. So we can restart the actual connector. We can also restart the individual tasks, and the tasks are the bit that actually, in the case of Elasticsearch, writing down to the target sink. So we can say, here are our tasks. So let's start off by saying, let's get a list of the tasks within that connector. Here are our tasks, pipe it through JQ. And here are our different tasks. So we can say, here's ID 1, it's for this particular connector, and there's the configuration that that particular task is running. And now we can say, let's actually get the status of that task. So with the task ID is 0. So if we were running a connector that had multiple tasks, so it's executing in parallel, we'd see multiple tasks listed out here, and the tasks would have different numbers. So we're going to do the status against this. So this is the API that we're going to use here, get the connector task status. So we need to specify tasks / the ID, and then the status. That's a get, and again we put it through JQ, and it says, okay, the status of that particular one is it's running, and there's the worker on which that task is executing. And now we can actually restart that individual task. So we can say do a post against that. So we're going to say do that and restart. And if we pull this down here, so we've got the log at the top of the screen there, and we do a restart, and now we can see that task there. Here's task 0. That did a bunch of stuff, and it said, okay, I've restarted that task. What other things can we do? We can say, let's have a look at we've seen deleting connectors. We can pause a connector. So this is going to pause the tasks. Okay, so let's do that. So now we're going back up to the connectors level, and this is a put against the connector and do a pause. Okay, so it's created that, and you can see here set the connector sync to paused. And if we do a status of all the connectors, you can see here our source, the Debezium one is running, the sync itself is paused. So if we send messages to that particular topic, we would imagine that task for the Elasticsearch one is going to do nothing. And when we want to resume it, we do a put against the resume. So let's do a put against resume. And now that's started running again. And we could prove that out if we actually put some data into a topic and watched Elasticsearch as the data flowed through. But take my word for it, it does what it says on the tin. So we've got our tasks. We can also find out information about the stack trace. So if you imagine something goes wrong with one of the tasks, You could do a status call to actually pull back that information, and you get a nice stack trace. We can see, oh, this is interesting, I think this is new. Get a list of connector topic names. Topic names the connector has been using since its creation or since the last time its active topics was reset. So let's pull that in. Let's say, so if we say sort and they're both running, let's try it for Elasticsearch. Okay, so Elasticsearch, so the sync tells us which topics is it active with at the moment, and it says, well, this topic is active at the moment that it's actually reading from. So I guess that's going to be useful if you've got things like a regex that you're matching against in your connector. So your connector can say, I want to pull in data from all of these topics that match this particular condition. So we could use this API for actually finding that out. And you could reset that as well. So can I reset it and then see what's been picked up since then? So we've got connector, plugins, that lists out the plugins. Validate one, this one I suppose you could use, I don't tend to. Validate says give me some configuration, I'll tell you if it's valid based on what the connector plugin needs to know. So if you're connecting to a database, can it connect to the database, and it won't actually go and create that connector. So that's kind of useful if you want to. I tend to just run it as create the connector, and if it works, it works. If it doesn't, then it tells you what the error is anyway. The last part of the Kafka Connect API is being able to change the log level of the different loggers that you have within Kafka Connect. So let me show you what I mean by that. So if we do a logs against Kafka Connect, so have a look at the Kafka Connect worker logs, which is where you get all your good debug information when you're trying to troubleshoot what's going on. You can see you've got like a bunch of info messages, and if we page up we might see a few warns or something like that, but it's relatively high level and it's not noisy, which is what you would hope. But when you're troubleshooting these things, sometimes you want to increase the logging. But if we restart the worker and we say set everything to trace, you're just going to get bombarded with stuff. Like you won't be able to find a needle in a haystack. So instead you say, well, we can pinpoint different loggers. So if you look at this one here, like that's a particular logger that's outputting that information. But you don't always know the name of the logger until the message has gone by, and you don't know which message you're looking for because you don't actually know what the problem is. So you get this kind of catch-22. And if you're restarting the worker every time, it could be you're trying to troubleshoot a transient condition and you restart the worker and then it just starts working. So this is where changing the log level dynamically comes in, because it's really, really useful. And what you can basically do is a REST call against the endpoint to see what different loggers are set up. And it will say these are the different loggers that we've got by default. We've got the root one is info, this one's going to log at error, this one's going to log at warnings. And then you can say, well, actually, I would like to increase a particular logger. So let's say we've got, oops, let's take the one from the article because it's easier. And we can say, I would like to increase this particular one up to trace. So we say, do a call against the endpoint. So it's a put against the admin endpoint, and you've got the loggers, then you give it the name of the logger. We increase that to trace. And now up here, you'll notice in the log, you've got these trace calls, and they're happening every second or so, and it's fairly noisy. So you might want to dial that down a little bit, but you can see it's like, we're going to send some records to Kafka and all this kind of stuff. So you can increase that, but you can also dial it down. So you can say, okay, we're going to switch that back to info, and we switch it back to info. And now up here, we don't get any more trace messages. We just get the info messages as they come through. There's a useful set of them. So like here's the ones for like debugging anything going on with the Debezium connector. So let's say we're going to paste that in. And so now anything that Debezium does, we're going to trace at a, or we're going to log at a trace level. So you can see it's polling for events. Here's the exact things that we're doing. You might say, actually, we only want information from this particular one here, the bin log reader. So then we could set all of those ones back to info, because you can see it's the IO Debezium logger. Set that back to info, and then say, well, actually, the IO Debezium logger, and it's IO Debezium dot, oops, the bin log, get my screens mixed up, this one here. So we say, okay, let's paste that one in and put that on here, and that one's going to come in at trace. So now up here we get just the information when it hits the actual bin log itself. So you could say all the other bits of Debezium connector we don't mind, this particular bit we're interested to see what's going on for it. And you can see exact same things with like the Confluent connectors, and any connector plugin in Kafka Connect will have its own set of logs that you can then dial in precisely and focus on just what you want. So this is really, really useful. So that is the Kafka Connect API. I showed you some really neat things that you can do. This is one of my favorite ones, where you basically take the output of all the connectors, and instead of getting a screen full of like, here's all the nitty gritty, it just says, let's format it into a nice table that looks like this. It's a sink, it's a source, the name of it, the status of the tasks and the connectors, and which class it is that's running. The trick with Pico is also really neat as well. So you can say, here's a list of our different connectors, which one would you like to delete? And that's probably all I've got to tell you about the Kafka Connect REST API. Go and check out more Kafka Connect videos on my YouTube channel. Make sure you subscribe to the channel. If you want to know more about Kafka Connect itself, go and check out this talk, which takes you all through the full nitty-gritty of Kafka Connect itself.